Okay, you're all welcome to today's class. Okay, today we are going to look at the topic Pythagoras rule as a right angle triangle, Pythagoras rule and application, then the Pythagoras rule in real life. So now, first of all, now look at it. Okay, what is Pythagoras? In the case of the Pythagoras, now we can't talk about the Pythagoras theorem without what? Knowing what a right angle triangle is. So now, we are a right angle triangle. This is a representation of a right angle triangle. Let this be our A, this is B, and then C. But then in this case, at this level or at this stage now, this is still a triangle. Why is it still a triangle? Because what? We have not yet what? Identified or point out where our right angle is. So if we now put a right angle here, now this is what? A right angle triangle. Now, and then what? If you are having something a right angle triangle, what? These sides are being named. This longest side here is being known as the hypotenuse. The hypotenuse. And then this side and this side is known as what? Is known as the leg, or we have what we now say base or adjacent, depending on the position of what? The right angle triangle. And then what? This is a hypotenuse, which is the longest side. But then, what if you're being given a right angle triangle that what? The measurement is all the same. Now, the easy way for you to identify when the measurements are the same is what? The side opposite the right angle triangle. This is our right angle here. The side opposite is what? The hypotenuse. So in all cases, either the measurements are all the same, because what? The simpler way that you can explain is what? The longest side, which is the hypotenuse. But in a case where what, all the measurements are the same, you what? Use this to be able to identify what your hypotenuse is. And then what? This one now, it can either be base, this can either be base too. This one can either be leg, in which what? It stand on, or this one too can either be leg, and in what? It can either be adjacent too, depending on the position is. And then if this is what? This sign represents 90. Angle 90. And then if this is 90, that means the sum of this and this will be able to what? Give you a 90, because what? The sum of an interior angle, the sum of an angle in a triangle is what? 180. So that what? If you add this, it should give you 90, plus this 90, it should be able to give you what? 180. And then one of the things that I also want us to look at is, now, if this is angle A, this is also, you can name this as well small a. Angle A, this is what? Side A. If this is B, that means this is what? Side small b. If this is C, that means this is what? Side small c. Now, but then this depends on the alphabet you use, because I may decide to use what? X, Y, Z. I may decide to use A, B, C, depending on the position that I write. But then you should know that what? The side opposite it should be the small letter, because what? The angles are being represented in capital letters, and then the sides are being represented in what? Small letters. So from here now, this is more of like what? A right angle triangle. But then for us to be able to what? To interpret the Pythagoras theorem, we have to what? Okay, we have already put it in this form, and then the Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse side, that means what? This side now, because this side is our hypotenuse side, the side opposite our right angle. They say the square of the hypotenuse is equal to the sum of the squares of the two other sides. Now, this, based on the interpretation now, they say the square of the hypotenuse side, which is what? B. So if we now say B square, they say the square of the hypotenuse, that means what? The square of B is equal to what? The sum of the squares of the two other sides, in which we can simply go with what? A square plus C square. If we are talking about sum, we are talking about addition. They say what? The sum of the squares of the two other sides. So from here now, this is more of like what? The what? Interpretation of the Pythagoras theorem. This is what the hypotenuse. These are the other two sides. So in all cases, no matter in all cases, either this is being given, this is not given, this is given. This is how the formula will be. But in the case of where what this is being given, this is being given, and then this is not giving you to find E, this still remains the same. What will happen in this case in the trying to solve is what? Making A the subject formula. Because in some cases, students normally make mistake by saying what? Since it is A that I'm looking for, then I'll say the square of A is equal to this. No. Because from the interpretation of what the Pythagoras theorem, it says what? The square of the hypotenuse, which is the longer side, which is this, the longest side, is equal to the sum of the squares of the two other sides. That's how what we were able to get this formula. So this is like what? This is a formula in solving Pythagoras theorem. And then from here now, we are going to look at some examples that it will give us a more clearer picture of this in a more simpler way for better understanding. Thank you.